Thank you, everyone. I really appreciate you being here today. I realize that lunch is also going on, and this is amazing that anyone is here right now when lunch comes out. So thank you so much for taking your time to be with us. We're going to talk about blocks, what I think is a very cool concept that can help make your life better when you're making different coding programs and projects with Python. All right, so I'm Jeff Hale. I'm a developer advocate at Prefect, and despite what I'm wearing right now, I'm often into Hawaiian shirts. So if you see somebody around, that might be me. I like getting outdoors, playing Ultimate Frisbee, and happy to chat about any of those things if you'd like to talk. I do a lot of writing and teaching about Python, often on Medium. If you hang out there, you might see some things I write. And I also organize events. I'm a co-organizer of the Data Science DC meetup. Anybody here from DC area? Yeah, a couple DC folks. Awesome. Check out what we got going on in DC. So I'm a big fan of Prefect, not just because they pay my paycheck, but also because they actually make it much easier to deal with a lot of common pain points and really solve those in an elegant way. It's an open source library and has a growing company behind it. It's a Python library, to be clear. And when people ask, why should I use this? Why should I be here talking about Prefect? Often I say it's about coordinating your data flows. Anybody here use Prefect before? A couple hands? Okay, a little back and forth. Okay, right on. It gives you observation and orchestration. That's like the big, awesome pitch. We'll talk a little bit about that, but that's not the main thrust of our talk here today. We are going to talk about blocks. And so there's a few concepts that are useful to know that you just might hear us slip into. Talk about using flow and task decorators. If you've used Prefect before, you know those are kind of a way to take a function and add some magic to it. Add some, in a good way, add some Prefect magic to it. And then when you want to really productionize things, you can turn it into a deployment. It just takes a couple of steps, but then it's something that you can use on a server. And then you can share things across a workspace with your other users. So those are a few terms we might use. Today we're all about blocks. So why might you want to use these blocks? Well, it can make collaboration easier. That's one of our big nice selling points of using blocks. You can cut down on your errors when you're trying to configure things, and give you some increased security over a lot of methods. We'll talk about that a bit. And much easier extendability. This kind of builds in an API interface that makes it easier to so you don't have to actually fork the code in the repo and go from there. Instead, you can just kind of have a nice way to extend it very, very simply. And in the end, hopefully save you a bunch of time, right? That's like our goal here, make our life easier, have a better experience, save some time. All right, so what are these blocks things? Well, at the end of the day, they're just Python objects like everything else in Python, right? But they do have a couple of special features. They do have a little bit of front-end magic that is really nice. And they work on a server, so you can use them in different places. So we'll talk about options there. And then Python is Prefect is a free open source library, but we do have, if you want enterprise features, we'll let you pay us for that. And we have some access controls at those levels. So these blocks, these objects are stored in server-side in either our open source Orion database that ships right when you get Prefect. It's a SQLite database by default, but if you want to go to Postgres, that's fine, you can do that. Or we can manage things and host them for you in our cloud so you don't have to worry about that. So blocks give you a bunch of choices. That's going to be one theme here. At risk of doing something I try never to do, I will read this out because it's right at that 25-word cutoff. Data practitioners have historically been forced to choose between the simple setup experience of low-code data integration tools and the flexibility of an all Python pipeline. Often it's just one or the other, right? You get a simple form, fill some stuff out, now you can connect to it, right? You've seen that before. Or it's like, here's a blank slate, here's some Python, go figure it out, right? Just do it all yourself. So, as the meme says, why don't we just do both? Prefect blocks is the solution to that problem. And maybe the only mullet reference of the day, you can think of Prefect blocks like a mullet. Structured form in the front, nice and easy. Flexible, let that hair flow in the back. Flexible Python code. So these blocks you can think of as low-code connectors. but actually have a first-class Python experience. Get the best of both worlds. So you're probably thinking right now, this is really cool. How can I get one of these? Well, if you use the Python package manager, pip install prefect, good to go. Make sure you have prefect version 2 here. We built version 1, learned a lot of things along the way. Blocks come in version 2, which we just released this summer to general availability. All right, so you actually want to make a block here. How are you going to do it? Said you can make it with a nice form. You can be in the UI. Just click on the little add button here. Say you want to make a secret block. You'll see there's a bunch of types. Fill out the little form. That's all you need to do. Give it a name and a value. Hit create. And then we give you a little code snippet that you can use in your code to use that block, to use that and get that value. It's as simple as importing the class, loading that block you made, and then actually accessing the value. And you notice that the value is obscured here, obfuscated in the bottom. That's a little bit of security feature we have, so you just don't have that sitting out on your laptop. So it's a nice way to make things a little safer. So that's option 1, use a form. Option 2, you're like, I don't want to use a UI. No, I'm a coder because I'm a coder. Okay, great. That's fine. You can just create with code. It's just a class, right? This block type is a secret class. So you can import it, create an object of it, and then save it. And then there you go. It's in your UI. You can use it right there. You got the same little code snippet. You can use it in your code. It's all just pretty seamless. Feels pretty magical. So you got flexible creation and then flexible editing. There's a little edit drop down there too in the UI if you want to do that. So that's a nice situation. So let's talk about like an actual use case now. All right, so we talked about secrets a little bit. Say you actually want to like share some provider configuration. This is something most of us have to do at one time or another if you're collaborating with other folks, right? So if you want to figure out like how should I share this information? How should I do this? Option 1, you could just like hard code that right in there. I'm not going to ask for a show of hands. We've probably all been there at one point, but you don't want to, right? I mean, Bitcoin prices are down to like 16,000 earlier today. Maybe it's 12,000 now. I don't know, but there's still enough money out there that you don't want someone using your AWS compute to go mine some Bitcoin, and that's a bad situation. So just don't hard code it. You don't want it getting in there some way. You can use environment variables. Environment variables are a pretty common solution to this problem, and they work pretty well, but they do have some shortcomings. They're often kind of viewable in logs and things like that. And they're tied to your machine, right? So you got to like get them out there another way. So it does take a little bit of work. Third option, you can use a secrets manager, right? Big cloud providers have these, but then you're tied to that provider. A lot of times it takes a little bit of work to do that. Oftentimes, if you're using something like a solution that's already there that works across cloud providers, there's a decent sized learning curve on some of those, right? And then you don't get all these configuration benefits, right? It's just like there's a secret there. So you might think, hey, this sounds pretty cool. I'll just like build this myself, right? We're all hackers. We want to go build things. So you can build a custom secrets manager. That sounds like a fun thing to you. Then you are not me. You have to add some configuration. You got to think about encryption. If you want to have this on a server to use with other people, you got to think about syncing that. It's going to take a lot of code and a lot of work, right? It's not something I would personally want to play with. So prefect blocks I offer as a solution to this. They are, again, obfuscated with PyDantic's secret string right out of the gate. They're encrypted at rest in the database, and you can use HashiCorp Vault or something like that if you really want to. We have an integration that our partners at Intel made, and we'll talk a little bit about how you can extend blocks in a lot of ways in just a minute. All right, you with me? Awesome. We're going to take a little detour now. Just a little historical context, a little fun time. I bet you didn't think you were going to get a history lesson here today, but you are. So, Charles Babbage. Who's heard of Charles? A couple hands? Yeah, maybe like somewhere. I think there should be like some documentaries and books about him. I'm sure there's some stuff out there, but it's wild. In working on reading up for this, I learned a little bit. This dude was super duper smart. right? Mathematician in the early 1800s. He was a philosopher, code breaker during a war. He was like breaking ciphers in 1850. Sounds pretty cool. Like no computers around, right? He was an inventor and invented such fun things as the ophthalmoscope. Probably butchering that, right? Didn't actually get it made in his lifetime, but this is a common pattern. He designed a lot of really cool things. He's got the cow catcher there, like big range, right? All over the place. Very useful stuff. And he made a difference engine, which is something maybe folks have heard of, kind of taking some ideas from a loom and how to like add some automation there. Started getting that produced a little bit, never had one fully made, and then iterated on that to make the analytical, or to design the analytical engine. Again, never actually completed, but pretty amazing. Like the forerunner of the modern computer. It had branching, it had looping possibilities. It was at least considered to be potentially Turing complete, according to something I read. So we'll see. It was never built, so we'll see if we got that. But pretty wild. And this is just a picture of a part of it. There are actually multiple pieces together. And it used the idea of punch cards. This is not a punch card from the 1800s. This is from the 1970s. I think my father might have used punch cards. I won't ask anyone here if they've used punch cards before, but pretty revolutionary. Back then, this idea was already being put into motion. And you might have heard of Ada Lovelace. She's been getting a lot of good press lately. She wrote the first computer program, is attributed as doing that, for Babbage's analytical engine. Even though the thing didn't exist, she wrote a program for it and like figured out how to do that. Like, that's mind blowing, right? Like totally wild to me. All right, fast forward, 1991. Guido van Rossum introduces Python or releases it to the world. He was working on it in the late 80s. Hopefully you're at least a little familiar with Python. You're here at a PyData conference, so I'm guessing you might have used it a little bit. And I don't know about you, but it was something that really was the first language I found that I was like, yes, I like this. This makes sense, and I feel like it's something I can build with. So huge kudos to everyone who's worked in the Python ecosystem and helped make the language what it is today. All right, so fast forward again, 2018. Streamlit's on the scene. Who here has used Streamlit? Maybe a third, a quarter? Okay, cool. This is just a little example of a Streamlit app. This is the front end here that I made that shows how to use visualization libraries and kind of how you can interact with them, and also shows the code that goes along with them. And the point here is that you can write in Python, make the whole thing in Python, and you don't have to think about the front end, JavaScript, HTML, CSS, any of that stuff. You get that front end for free. It's pretty awesome. I'm a big fan of Streamlit. So this makes it so that as a Python developer, you do not need to think about having the skill set to do those front end type things. It's very nice, and it's useful for data apps and putting them into websites. Also in 2018, Jeremiah Lowen gives a talk at PyData DC. Anybody at PyData DC in 2018? Wow, okay. Wow, that's awesome. All different faces here. I was there, and it was super fun. And Jeremiah gave a talk called Task Failed Successfully, where he kind of introduced Prefect and the workflow orchestration idea behind it. And then 2019, Prefect 1 actually comes out for general availability in the spring. 2022, we did a whole rewrite, release that to general availability just about 4 months ago. And this is what actually includes some blocks here. So with Prefect 2, we've got blocks that allow Python developers to build this HTML interface pretty easily. So similar, you don't have to think about making that form you saw, right? It's just like there. It ships right away. But it's different than Streamlit in that Streamlit's really targeting a front-end, like web app kind of environment here, whereas Prefect blocks are really trying to get your configuration in so you can use those then in the back end on your code. So different purposes, but same idea of like lowering the barriers where you don't need to know about these other languages. Okay. Thank you for the little journey down history lane there. Hope you enjoyed that. Let's talk about block types now. So there are a whole bunch of different types of blocks that Prefect ships with right out of the gate. We've got strings, date times, JSON options. You get a secret that we saw. Those things are available right away for you. But then there are other things, and they're still blocks, but they're specialized for different use cases. So if you want to store your code somewhere to run in the prefect kind of world, you can do that on GitHub, or any of the major cloud providers here. You can put it in AWS and S3, Azure, GCS, whatever you want to do, other remote storage. You can make a block for that, and those are just there for you, ready to use. And you don't have to think about like, oh, what are all the things I need to make this connect? You have a form that makes it easy. If you want to run your code in certain infrastructure, Docker, Kubernetes, whatever it is, those are available right out of the gate, and then there's other options that are extendable too. If you want to get notifications when something doesn't work how you want it to in your code, you can get those, use blocks for that also. There's notification block types like email. I mean, I know it's like the kids aren't doing it these days, but like maybe most of the folks in this room are still using some email. We got Slack, webhooks, Microsoft Teams. We just added a Discord option here, so there are a lot of different ways that you can get notified if something goes wrong with your code, which is super great. We have stories of users who were on a train, got a message, oh, something didn't work. All right, cool, I can get in and fix it. Done. All right, let's look at one particular type here. We have this AWS S3 block for storing your code. You're going to have things run on a schedule. It's going to be able to access that code. It's as easy as in the UI, if you want to go this way, hit the add button and put in some information for your block name, bucket path, and if you have some access key information, you can throw that right in there too. Hit create, there you go. So now you have a colleague who maybe doesn't want to like touch code at all, and they were able to use that form to get in some configuration information for you. So if you have a teammate who's like, nah, I just do SQL, or I don't want to do any of this, like maybe you can still give them access so you can collaborate with them. And then we have blocks like we saw for notifications. So for example, you make a little Slack notification block UI, and then boom, you got some code you can use. Just grab that code and go do it, and get notified if something goes wrong or something goes right. So we have a user who has pricing data in their code, and they're kind of monitoring pricing for their use case. They want to notify someone on their sales team if the price goes up too high, above some threshold. So you can do that. You can do that in your code, and then call a notify method. It comes for free with a notification block, and it'll notify them when that target was met. So it's a nice way to collaborate with people who maybe, again, aren't Python developers. Someone on the sales team can still get that information super easily. And think about like what it would take for you to like build that all yourself. Probably some work, right? So it's a nice free feature right out of the gate. So there's a bunch of different block types out there, but blocks are like totally extendable. So if you want different block types, you can check out Python libraries. We have people in the community or Python developers who've made all kinds of different things. Just an example of some of the different logos here that you might recognize for things that you could use to extend the capabilities of blocks. So these are collections, and these are just pip packages that you can install, and then most of them give you some block superpowers. So again, Snowflake, DBT, Monte Carlo, things like that. Great expectations, view, hex, all kinds of possibilities here. And these are just some of them. But if you want even more block types, that's great. You can create your own. Again, these are just classes and objects, so it's not hard once you have Prefect installed. You can just import the core block class, subclass it, and you're on your way. We've got a get volume method here. This is just taken out of our docs, and it's really just a couple lines of code to start building your own blocks. Once you've made a new block, you somehow need to tell the server like that actually exists, right? Whether you're using just like a local server or using our cloud product, whatever what we want to do, somehow have to tell it. So you can use a command from the CLI. If you've used Streamlit or Flask or lots of other things, you're used to Docker, whatever it is, you're used to saying, okay, I'm just use a CLI, go for it. And then boom, the block shows up in the UI as something someone can input data into. So you get that cool form code first experience, whatever you want, a lot of flexibility. And as you might expect, we got like all the helpful things, docs and a community Slack with over 20,000 members, recipes you can use for lots of different use cases. You have blog posts and doc strings and things like that. But I want to call out that we have this CLI -- help here. If you've ever been on a CLI trying to use some commands and like, oh, I don't want to refer back to the docs, I don't remember how to use this, you can always just say -- help after pretty much any command, and you will get some documentation right there in your CLI. Using Rich, we're big fans of Rich. I don't know if anyone's used that library over at Prefect, but it's really nice for working with the CLI. And you don't have to be able to read every little bit here, but the takeaway is it can help you on your way and just do it right in the command line. So we think that's pretty cool. All right, a couple benefits here of blocks to hit. Fewer errors, I mentioned that before. You don't have to like think about what am I going to use for configuration here. Someone's made a block, you have one of ours off the shelf, that information is available to you right away. Just fill in the form fields, right? Some of them are optional, if they're noted, that's fine, it's required, it's going to be noted too. Blocks are composable. So you can use different blocks together. You can throw them all together in your code just like you would. You have that flexibility. Blocks are nestable. These are nesting dolls, if anyone's familiar. You can put one inside another. Get the little visualization metaphor there. So here's two blocks. We have a registry block where we have some information, some configuration information for your Docker registry. You can then refer to that in your Docker container. And in fact, it's right there in a form field. So you can have a little drop down and it'll pull up any of your Docker registry blocks that you used, and they're right there. You have that information. And you can add new ones right off the button too. So blocks are super versatile. You can have this kind of same core concept, and we talked about how we use this in lots of different ways. It's all over the place in Prefect. We're even using anonymous kind of blocks, and when you don't want to have to think about things under the hood. We're just talking here about kind of the blocks that you're going to be making, but blocks are a really central thing that we're using a lot in Prefect. So we talked about roles with storing code, using infrastructure to run things, notifications. There's a lot of ways you can use blocks. They're just Python classes. And some bonus. So blocks are totally reusable. This is really cool. You make it once, keep your code dry, you can use it a bunch of different places. And you can even share it with other people in your workspace. This is the most clip-arty picture I could possibly find for sharing. So I went with that. It's just like sharing some puzzle pieces. I don't know what those things are doing. But you can share your code. You can share your blocks across with your colleagues, right? That's super nice. And then blocks are extendable. To quote one of my colleagues, blocks people don't need to fork Prefect to extend it. Like, we have an interface for you to just go hack on it, right? This should make life easier, faster, and better. All right, you're probably asking yourself right now, what else should I know about Prefect? I'm glad you asked the question. So we like to think of it as a really great option for data flow coordination. This is just Prefect overall, not talking about blocks right now, but it gives you like a whole bunch of cool things, right? Automatic logging right out of the gate. Anytime you throw a flow decorator on a function, you get retries super easily. You get scheduling. That's often a thing. I think we've all want something to run on a schedule at some point in our lives. You get notifications. Because again, we saw those before, super cool. When things don't go well or when they do, you want to get notified, you can do that. You get caching. Caching is one of those things one of the two hard things, right? Like naming things and caching. Maybe there's others, but those are like two that always come to mind. Off by 1 errors, yeah, okay. If you think hard enough, you can think of other things that are hard too, but those are a couple tricky things. And then async. I would say maybe async sometimes is a tricky thing, especially getting started, especially maybe in Python. There are lots of different ways to think about it. We have integrations with things like Dask and Ray for parallelization. We have async support for concurrency right out the gate. So we have lots of options there. Collaborative UI, you've seen that. And I'll talk a little bit about our hybrid model. Like, we are all about security and you keeping your code and your data on your machines, and we not touching it, right? We want to have things on our machines. This helps with all kinds of compliance issues for you, for us. It's win-win. And then we have lots of integrations. You've seen that. Kind of anything in the modern data stack you might want to use. Probably have an integration for it, or if we don't, we'll soon. And then incremental adoption is one of those things that makes you say, huh, what does that really mean? It means you can bring your own Python code. This is just a super easy start here, hello world kind of deal. I'm just gonna have a hello function, print out something. All you have to do is add an @flow decorator after you've imported it, and you get automatic logging down at the bottom, right? You're already starting to have some information stored, starting to get some value right away. So we wanted to make it super easy to get started, and then as you grow and need more, you can learn more, right? We want to just make it easy to go all the way up. You want retries? It's as easy as passing some value to the retries parameter here in your flow decorator. So super, super quick, right? If you want some notifications, you make that notification, use notifications in, we got a couple ways you can do it. One is you can use a block, or you can just do it right in the UI, again, with the notifications like here. I want to hear this flow failed or passed or whatever it is. And again, you can get it through email, Microsoft Teams, Slack, and soon to be Discord. It's done. We just got to get on the UI. It's probably this week. All right, so briefly, mention Prefect Cloud. Okay, this is great. We're using, we can do this all ourselves with open source, but a lot of times you don't want to deal with hassles, right? You want to have kind of a hosted managed solution. That's Prefect Cloud. We give you a free tier with lots of good stuff, you can do everything you want to do there probably. But then if you're an enterprise company and you want to have those enterprise level controls, we will let you pay us so that we can fund development of all the other good stuff. So this is kind of what the interface looks like here. Whether you're using the open source or the cloud interface, you'll get a nice usable UI. And if you're using the cloud, you get a hybrid model, again, where your agent is running your code on your infrastructure. Bring your own infrastructure. That's one of the things we want to do with Prefect. We don't want to be touching that code. We don't want to be touching that data. So other things to know about Prefect Cloud, we just passed 2 billion task runs, which is one of those things that would, I think, take you 60 years if you were counting them straight, right? Like 30 years if you count to 1 billion. It's a big number, right? So this is definitely being used by lots and lots of folks. I'm going to leave you with kind of one more blocks metaphor here. I think metaphors are super great for understanding new concepts. I'm always trying to make things accessible using metaphors. So the block and tackle, I feel like is one of those things we don't hear a lot about these days. We've got more powerful tools out there, but it's a pretty cool idea. Using some pulleys and ropes, you get some mechanical advantage, right? So it's like a force multiplier. If you have 25 newtons here of force and you use this double pulley system, then you can get 100 pounds of force moved, right? 100 newtons moved. You get that force multiplier through mechanical advantage. So similarly, Prefect blocks allow you to do things more easily, get more done faster, and I think that's the goal for all of us here when we're coding. So I just did it one more time here. Why are these blocks great? Well, kind of like Streamlit here, right? We have this interface for HTML so that you don't have to think about it. You can use a form, get that information, use it on the back end, use it in your code. Hopefully resulting in fewer errors, give you some more security benefits when you need them at least. And they're composable, nestable, versatile, reusable, shareable, extendable, all the olds right there. Really a lot of nice things to go with Python prefix blocks. So when you're thinking about things here and you think about your next project, I encourage you to think is this something I could use that would be helpful to me? And I'm very curious to see how you use it. So thank you for your time. Curious to take any questions you have about blocks. Yeah.
Great, thank you so much, Jeff. Any questions?
Thanks, Jeff, for the useful information. So I have to have one question regarding blocks. You did talk about you can share it across with the different teams. Is there a way you can configure when a timestamp, like your block can be effective from this time to this time, and after that nobody can use it, or even if they use it's not good anymore?
That's a really interesting idea, like kind of a lockable block after a certain amount of time. The current answer to my best of my knowledge is no, but that sounds like a great feature request that we'll put in the GitHub repo, because that sounds really cool.
Okay.
That's a neat idea. Yeah.
Thank you.
Thank you.
Other questions?
Something that interested me was the move from explicit DAGs to the so-called DAGless. So how does interdependencies between these little blocks get managed? And how can I say, as long as these other blocks exist, I can build, my little, say my flow is building a model, and the previous flows were building the features and the data. How can I make those dependencies all work seamlessly?
Yeah, okay, cool. So this question is getting at kind of the orchestration aspect of Prefect. And so with Prefect 2, one thing we learned is that we want to give people more flexibility and not have to have data run in a DAG model, a directed acyclic graph model. We want to give people the ability to do looping and things and more complex logic. So we have in Prefect 2, there's a radar chart that isn't just like lines and arrows, but more like a circular chart with things going in different directions. So to the extent, like the block information is there and is usable, like people aren't generally like updating the block information as they're going through it. So it's more just the information being traced through flows. And without going too far into it, our tasks and flows are able to kind of track that state information and use it through a method of prefect futures. So we can maybe chat more about that afterwards, I think. But the block information that's kind of just there as a configuration option is available the whole time to any of the flows that are running. So it actually doesn't require anything special for it. But good question, thank you.
Yeah, so I guess since I don't know much about Prefect until this this talk, what would you say is the main use case for blocks that that you're seeing in your day-to-day? And would an example be like embedding such a block in something like a Jupyter notebook or something like this? Or is that not even like part of the scope of, like, where would I see that block in the wild?
Where do you see in the wild? Yeah, it's a great question. So this is one of the tricky things about blocks, is because they're so versatile and all over the place, really. They're used in Prefect in so many different places. So anytime you are storing your code somewhere, like we are using a block behind the scenes. The question is, do you want to go and like explicitly say, I want to put this in my S3 bucket and do it there, and you want to like do that? If you don't, we'll just have it running locally on your machine, and we're like working behind the scenes. But there's blocks. It's blocks all the way down almost with Prefect. Lots and lots of blocks. So we see people using them in all kinds of different places. Lots of people doing notifications. Lots of people storing code in different places. Lots of people using infrastructure and all kinds of different setups. So lots of places. It doesn't like jump right into a Jupyter notebook per se. We do have an integration with Jupyter notebooks, so you can use Prefect with Jupyter notebooks. But it's something more where it'll always be there on the UI when you want to go check it out. It's on the server and it's visible there. And then you can use it in your code as you are making flows and running your code in Prefect. Or some of these work with deployments very well when you're like kind of more productionizing things and you want to say, I want this to be something that I can use. It's kind of pull code from S3 or something, and run on a Docker container, whatever. Like you can specify it there on the command line when you're making a deployment or in your Python code. So lots of use cases. Yeah. Some other question.
The question in the back?
It seems like a block can do just about anything. And so I'm having trouble wrapping my mind a little bit around a concept of something that can do that much. Why do we call it a block and not just think of it as like a Lambda function or something a little bit broader?
Yeah, it's a good question. I mean, that's always a tricky thing, naming things. We are at one of the tricky things here. And blocks are, I kind of try to use a lot of different images of things that actually were blocks, right? Because in the world, the term block is super flexible, right? It's a building block. You can build other things out of it. And it's something that it's kind of a concrete term, which I think is helpful when people are like thinking about how it works. Because we want to differentiate it from something like a Lambda function, because it does have like this front end UI aspect to it, and it's got things that a Lambda function by itself, at least, isn't what I think of, right? So it is a really hard thing. I don't know what the original thought was on going with the term blocks, but I think it's kind of like general utility, a lot of different ways you can go about it, and something you can build with. So I think there are kind of a number of different ways that physical, metaphorical term does work well in the digital space. So I kind of like it, but I'm a biased source. I've been using it for a while. But it is a tricky thing to kind of explain and wrap our heads around, right? So that's why I'm excited to be talking about it here and trying to really make it what I think is a very cool concept, but also like make it accessible to people because it's a kind of a new concept. But thank you. The question was, what shouldn't you do with blocks? That's a good question. What shouldn't you do with blocks? You might have stumped me. I mean, if you want to do something that you want, like use the right type, I guess is maybe like if there's something that's already there. Like it's nice because using using the benefits of pydantic, you can do things like have that secret string obfuscation and stuff. So if you want to use that, like just make sure you use that under the hood there too. So maybe just like choices about like using something that works well for your use case is mostly how I would go about that. But it's a good question. I'll try to think of more.